So hello and welcome friends to our channel Intro Mech, and here we discuss about basic mechanical engineering concepts. So guys, we have just finished our series based on the selection criteria of solenoid valves. So this is just a summary of those parameters. Those people who were unable to see the previous videos can directly see this video to get a basic idea of the parameters. So without wasting time, let's get started. So in our previous video we have covered the first 5 principles. So now let's see what are the pressure, temperature, response time, voltage, IP rating, these parameters, and how they affect the selection of solenoid valve. Right, so let's check out these parameters. So we have covered the first 5 parameters in our first session. You can check out that video also. I will drop a link into the comment section, and today we will cover the next 5 parameters in brief. For detailed explanation of these parameters, do check out the previous sessions. So let's check out the pressure. So the pressure plays an important role. Like we have seen, there are different types of solenoid valves: the direct operated, then we have pilot operated, semi-direct operated. So all these valves have different pressure requirements. The pilot operated valve requires some kind of pressure differential maintained over the system. So that's why we should know what are the pressures of the system, and how the pressure is getting dropped across the system, what are the pressure losses. So there can be different valves for gases or liquids. Definitely for gases and liquids there can be different valves, or the same valve can be used for gases and liquids, but the parameters might change. So we should know what is the media and how it will affect your selection, right? So this is the pressure parameter. And then we have temperature. So temperature is also important when we select the valve, right? So let's see the temperature, because let's say the specification of some minimum and maximum temperature while selecting a valve. Because let's say if you are using a valve for water, you know that the freezing point of water is 0 degrees Celsius. So the water might get freezed into the valve and can damage the valve. So you should know what is the minimum temperature of the operating fluid and how far we can go, because this thing can damage the body material of the valve, the seal material. So for that purpose we have some chemical resistance chart over here, where you can find the valve body materials, what are their types, what are the properties of these body materials. Then we have different kind of seal materials, right? We have stainless steel, nylon. Then we have seal materials. You can see EPDM, then FKM, PTFE, NBR, all these seal materials, and they have different properties. They can sustain different temperatures, different chemical resistance. So we should know that what is the media, what is its freezing point, what is its boiling point, what is its chemical affinity towards these materials. Otherwise it may damage your seals and there will be some leakages, right? So all these things are interdependent, and that's why we should know these things. Now we have some chart over here which will show the chemical resistance for some liquids and gases, right? So plus indicates the suitability, 0 indicates the limited suitability, and minus indicates the unsuitable nature, right? So we can read the media, then we can check out that which material is suitable for our media. And you can see there are almost 300 to 400 materials listed out over here. So you can definitely check out this site. You can see the IPDM is suitable, SS is suitable, brass is suitable for the acetaldehyde, right? And likewise you can check out all the other different materials over here, right? The different solids, then some liquids, gases, and all those things are mentioned over here, right? So this is very helpful and you should know this. So many materials listed over here, right? So wood tar or wood oil is also given, so you can check out which body material, which seal material is suitable for these things, because each one has different density, different viscosity, the chemical properties are different, right? Then we have a response time. The response time is very important and very crucial as far as the cycle time of the system is considered. The response time is nothing but the time required to, let's say, on or off of your solenoid valve. It will be in, say, milliseconds, but will affect a lot if the cycle time is crucial. And it doesn't mean that your valve timing should be always less, because let's say in case of water hammer emit, if the response time is very less, it could cause a damage to the system. So it will also vary according to the application of your system, because in case of water hammer let's say thing, you will require a valve which will have some larger response time. So that is why this response time is also important, right? The maximum rated operating pressure of the valve is higher than 6 bar, then the response time will be measured at 6 bar. So these are some guidelines that how it is calculated, right? The response time of DC valve is a bit slower than the AC valve. Again, based on the AC DC, the response times are different, right? Then if we have a direct operating valve, generally they are faster than the indirect or the pilot operated valves. So again, which type of valve you are using, so all things are interrelated, right? So you have to think upon for all these things. Common valve, common values for direct operated valves are between 5 and 50 milliseconds. For indirect operated valves, the response time may vary from 50 milliseconds for small versions to 1500 milliseconds. So it's huge. So depending on your type of valve, the response time will change, and you could see for some application a short response time is not desired. For example, the water hammer, we have discussed this right now. So for water hammer, we will require the valve having a larger response time. So it is not the thing that always we will require a valve with a shorter response time. So that's how you should keep this thing in mind, that on the basis of the application you have to go for a valve, and you should check the response time of the valve, right? Then there are some installation tips of the valve. You can just check out. Those are just installation tips, that how the valve should be installed, vertical, what should be the direction of the coil, and all those things, right? So this is important for the installation of the valve. Then we have the voltage and the coil. The voltage rating of the coil is also important, that whether you are going for an AC valve, whether you are going for a DC valve, so that is important. And we know that there is a coil inside valve, and which converts the electrical energy into the motion. So that is the basic working principle of the solenoid valve, we know. But but how to give the electric supply, whether it should be DC or AC. Then again, if we go for a DC, whether it should be 24 volt or let's say 12 volt. So it depends on your valve size, then your operation, which type of valve you are using, and so many other things, right? So you should know these things, and you can select the valve according to the voltage rating. When you select the valve, there is always the voltage rating mentioned into the catalog. According to that, you have to select the valve, right? You can read the information given over here, right? Then the effect on the characteristics, you can go in this, what is the solenoid valve working, AC versus DC. This video you can check out what are the differences between AC and DC solenoids. You can check out then you can use the AC coils with DC current, and all those things are given over here. You can just check out these things. These things are more of a electrical kind of thing, but we should know the basics of the things. So you can watch out this video. I will drop a link of this video into the comment section, right? And then we have the IP rating. So IP is the ingress protection. So this is kind of protection to the wall, because we will be using the wall in different situations. Those can be hazardous also. We have to use the wall in, say, some dangerous environments, let's say mines or underwater. So based on that, the wall should be like resistant to water or dust and all those things. So this is exactly what the IP rating means. It has a 2-digit number. The first digit indicates you can see the IP65, it has 2 digits. The first digit is the protection against access to the hazardous parts and the objects. So you can see 1 2 3 4 5. So if we select 2, that means the wall will have the resistance to the objects which are below 50 mm size, right? Then the second digit indicates the protection grade against the ingress of water. So you can see the numbers, no protection. Then 2 is the protection against the dripping water, then spraying water, then we have splashing water. And if you have the application directly under the water, you have to go with 9 number, which is the immersion protection up to 1 meter. So this is how you should go and select the IP rating. That is also important. You should check what is the IP rating of the wall you have selected, because let's say if you are using the wall into the mine, it should be dust tight. So you should select 7 number. If you are going underwater, the number should be 9. It must be like resistance to water. So that's how the IP rating is important. And sometimes the customer also asks you that I want a IP rating of, say, IP67. So you must know what is the IP67, and according to that, while selecting the wall, you should check into the manual that whether the wall has IP67 rating or not. So that's why it is very important. So this is it for our today's session. We have covered some of the important parameters in the today's session. That this is just a summary. For more details, you can just check out the previous sessions, right? So this is it, guys, for the today's session. So thank you guys for the patient listening, and if you have any doubts, please do write into the comment section. Until then, keep intro making. Thank you for the patient listening. Thank you.